Hi everybody, we're going to be starting out in our packets on page 4. You're also going to need your calculators out, so be sure to take those out. And you'll probably have enough room to do it right on the bottom there. So we've got cell phone price has been steadily dropping. In 91, there was a brand that was sold for 330. In 1992, its price was 287. Assume the price drops by the same amount each year. So it goes down by a set amount the first year, then that same a number of dollars the next year, then the same number of dollars the year after that. Well, what kind of function is this? This is a linear function. If you go up or down by the same amount every time, that's always linear. So we need to think in the form y equals mx plus b. Our b value is our starting amount. We started with $330. So we're going to have plus 330 on the end. Now our m should be what we're changing by. When you go from 330 to 287, we're going down, so it should be a negative, and we're going down by $43. So we're going to be having minus 43x plus 330. Whenever you write an equation, you got to tell what x and y represent. Well, y is our price, and x is years, but we have a calendar year, so it should be years since 1991. So let's make sure we've answered everything they've wanted. Find a function, we did that. What kind of function is it? We did that. And now we want to use this function to estimate in 1995. Well, 1995 is 4 years after 1991. So we're just going to sub 4 into our equation. So I have minus 43 times 4 plus 330. And take a minute to sub that in your calculators and see what you get. Make sure to put a label on your answer. So we should have gotten 158, and our units is just dollars there. So the dollar sign is your units for that one. So moving on to part B, assume now it drops by the same percentage each year. If you're changing by the same percentage, that is exponential. So we're going to have, first we'll just write this as exponential. So we're going to have something in the form y equals a times b to the x, where a is our starting value and b is what we're multiplying by every time. So we're starting with 330. Well, to find what you're multiplying by every time, they didn't tell us the percent, so that's where the successive ratio comes in. So to find your successive ratio, we did our second divided by our first. So we're going to do 287 divided by 330, because that's our second divided by our first. And what I'd like you to do then, put that in your calculator, and we'll say let's round it to the nearest hundredth. And whatever that is, your successive ratio is just what goes in as your b value. That's already got the percentage subtracted in this case because it's decay. It's just whatever you sub in for your b. So again, divide that, round it to the nearest hundredth. So we should have gotten 0.87 for that to the nearest hundredth. Well, we've got to tell what x and y are because we just wrote an equation. So like on your test coming up, make sure to write what x and y are with your equations. It would stink to lose points for that. So x is still our years since 1991, and y is our price. Let's see if we've answered all our questions. We found a function. We've said what type of function it was, and now we again want to find in 1995. So that was 4 years after 1991. So we're going to have 330 times 0.87 to the fourth. Now we're dealing with money, so we would run around to the nearest cent. So take a minute, sub that in your calculator, write down what you get to the nearest cent, and make sure to put your label on it as well. So to the nearest cent, we should have gotten 189.06, and that was dollars. For part C, we don't have a grid for this, so we're just going to do it on the calculator. So let's go to a graphs page, and we're going to graph both of these on the same axes. We've got the minus 43x plus 330. And then we've also got, if we hit tab to graph the other one, we've got the 330 times 0.87 raised to the x. So those are our two functions. Now we are starting up at 330. So let's make our y max there if we double click it, someone more than 330. So I'm going to put 400 just to be generous. And there's our two functions there. So the blue was our linear one, and the red was our exponential one. The x-axis is showing our years after 1991, and our y-axis is showing the value. And we want to think about, for that last question, part D, we want to think about which one seems more realistic, which model. And a big thing to notice here is notice somewhere between years 8 and 9, the linear one dips below 0. So that means at year 9, the linear one, they would be paying you to take the cell phone. So that's probably not realistic. So therefore, the exponential one is probably the more realistic model. It continues to decline, but the customer is still having to pay something for the phone. So we're going to move over to page 5 now. And we'll give you a moment to read through question 3. All right, so there's a lot of questions in there. So let's number each of the things. So the first thing they want us to do is find a function. So I'm going to number that number 1. Then the second thing we want to know is what's the value of the car on May 1st, 2000. So we got to make sure we answer that. In what year will the value be 8,000? So we'll put a 3 on that. And the fourth thing, we got to estimate the rate at which the car is decreasing. So there's 4 different things we have to answer. So let's start with number 1. They told us we're changing by a percent, so that needs to click in our head exponential. We were starting with a value of $14,000, and then we're going to have something raised to the x. Well, just like in the last one, we got to do our successive ratio. We got to do our second divided by our first. And like we did on the last one, we're going to round that to the nearest hundredth. So take a moment, put that in your calculator, see what you get as a decimal to the nearest hundredth. When you put it in, do Control Enter instead of Enter, and that'll give you the decimal right away. So we should be getting 0.83 for that. Right with our equation, we should tell what x and y represent. Well, we started out May 1st, 1995. So this is the years since May 1st, 1995. So they're just not starting at January 1st in this one. And y was the value in dollars. So that's our first question. The second one, what's the value of the car on May 1st, 2000? Well, 2000 is 5 years after 1995, so we can just take our equation and sub in 5 for x. We're working with money, so we would want to round to the nearest hundredth. Take a moment to punch that in your calculator and put a label on your answer. So we should get $5,514.66. Make sure you have your dollar sign on there for your label. Well, the third thing we wanted to find is, in what year will the value be 8,000? Well, 8,000 is a value amount, so that should go in place of y. So we'll have 8,000 equals 14,000 times our 0.83 to the x. To start trying to get x by itself, we'll divide by the 14,000. When you divide that, we should end up getting 4/7. So we'll have 4/7 equals 0.83 to the x. To get an x that's in the exponent, we need to do a log. So the base of your log is always the same as the base of your exponent. So we'll have 0.83 as the base of our log. The thing that was by itself will become the inside of our log, and now x is alone. Take a moment to punch that in. And we should get 3.003 and then some other stuff. So we want to know in what year. Well, if we're starting out May 1st, 1995, if we add 3.003 onto that, that's going to put us in 1998. So if you have a calendar year and you're finding years, make sure you put it back in a calendar year for your answer. Now our last one for this question, we want to know what is the rate. The car's decreasing May 1st, 1999. Well, 1999 is 4 years after. And whenever we do a rate, we want to think slope. Our technique for finding the slope is we do that value and we do 0.01 later. So 4 and 4.01. So let's go to our calculators on a calculator page. And let's get our y values. We'll do the 14,000 times 0.83, and we'll do raised to the fourth. And we'll also have to do our 14,000 times 0.83 raised to the 4.01. So going back over here, our y values, we have 6644.164 dot 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 dot. Okay, we need to make sure we keep these all the way out. Don't cut them off early. 6631.796 dot 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 dot. Well, now we need to do our change in y over change in x. We'll do 6631.996 dot 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 minus 6644.164 dot 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 over 4.01 minus 4. So on our calculator, let's do our control divide to get our fraction. And all you got to do, oops, and all you got to do is scroll up, select the value you want, minus, we'll scroll up and get the other one. And then in the bottom, we'll have 4.01 minus 4. So by scrolling up and hitting enter to bring it down, you don't have to type in all of the decimal values. And we get that for our rate. So it didn't say where to round to, so we'll keep it out to a couple spots, maybe the hundredth. So we're going to have minus 1236.85. And now we need units. Well, your rate's units will always be something per something. Well, a slope is your y's over your x's. So it's always your y units per your x units. Our y units, we had dollars. So it's dollars per, and the x units was years. So dollars per year. And just think about if your answer makes sense. Our price was decreasing, so it makes sense to get a negative rate. All right, going to the next one on page 5. There's questions from long ago. Okay, very few people have VCRs anymore, but the price of a VCR in a department store over 5 consecutive years is shown. We're going to graph the data and see what would be a reasonable model for this data. Describe what each constant represents. We're actually going to skip that part, and we're going to just come up with a function for it. So the two main things we've been looking at are linear and exponential. So let's check linear first. This one is going down by 25. This one is going down by 22. That's not the same, so that rules out linear. So that means we must be working with exponential. So we're going to have y equals 245 times something to the x. To find that something, we can do our successive ratio. We'll do our second divided by the first. And when we do that to the nearest hundredth, we're going to get 0.90. Now, if we had done our other successive ratios, like the 198 divided by 220, it may not be exactly 0.90, just because they probably had to round to whole VCRs, but it should be about the same. So X is our years since 1991, and Y is our price. So we want to find what is the price in 1997. So we're going to have y equals 245 times 0.90. And in 1997, we started in 1991, so that's 6 years later. So we'll give you a second to punch that in. We're working with money, so make sure you round to the nearest hundredth. And when you punch that in, you should get 130.20 dollars. Well, the next one, what will be the price in the year 2000? 2000 is 9 years since 1991. So we'll have y equals 245 times 0.90 to the ninth. And this one would give us $94.92. And it seems realistic that the price should decrease over time. Now our domain and range for this, so our domain, time can go on forever, so we'll have x is greater than or equal to 0. But for the range, our value of 0, it's probably never going to actually hit 0. And because it's decreasing, it's going to stay below 245. So y is going to stay in between 0 and 245, but not including the um, 0, because the price, when it's exponential, will get closer and closer to 0, but never hit it. That's it for this video. Have a great rest of your day.